Hi, Old Bridge students. You're probably sitting at home with your ball and stick models, building your compounds. You're probably, if you're like me, you have your CH4, you got your methane, and you got your O2 and your oxygen. You're thinking, well, these atoms are going to rearrange in a chemical reaction, and we're going to make our carbon dioxide, and we're going to make our water. All right. Unfortunately for me, I don't have enough. So what we're going to look at instead is a simulator to look at these. So we're looking at one of the FETs that we would normally use, and it is a tool to balance a chemical reaction. So we have the CH4 and the O2 forming CO2 and H2O. So if we were to classify this type of reaction, we see the CO2, we see the water, that should be the giveaway, the carbon-based fuel, and the oxygen, this is a combustion reaction. All right, so the goal of this activity is to get the number of atoms equal to each other before the reaction on the reactant side and after the reaction on the product side. So right now, I have one carbon, that's good. I have 4 hydrogens, only 2 hydrogens, and then I have 2 oxygen, and now I have 3 oxygen. So if I'm balancing a combustion reaction, I always want to do it 1, 2, 3, carbon, hydrogen, oxygen, right? That 1, 2, 3. So carbon's good. I'm going to add a second H2O molecule as a product to balance the hydrogens. And now if I recount my oxygen, I have 4 as products. I need 4 as reactants. And look at that. I get the smiley face. All right. We have a couple reactions on here. The separation of water. If we look at the separation of water, we have 1 oxygen in red. Now we have 2 oxygens in red, 2 hydrogens in white, 2 hydrogens in white. Hydrogen currently balanced. I'm going to add a second water molecule to balance the oxygen. Now the hydrogen's unbalanced. We have 4 reactants. We want 4 products. We get the smiley face. And making ammonium. N2 plus H2 forming NH3. The N is blue, so we have 2 N's, now only 1. The hydrogen is white. We're going from 2 to 3. All right, first thing I'm going to do, I'm going to double my nitrogen as a product. So now my nitrogen is balanced, 2 forming 2. I have 1, 2, 3, 4, 5, 6 hydrogen atoms as products. So I'm going to add 2 more hydrogen molecules. That gets me to 6 atoms, and I get the smiley face. So what I just want to think about when we're trying to balance reactions, we need to have an idea of what these things look like at the atomic level, right? So if we have something like helium, it's by itself. H2, we're seeing the 2 hydrogens together. O2, they're together. Cl2, right? We're thinking 2 of these atoms. We can see bigger subscripts, O3, S8. All right, elements can be molecules. We want our atoms to be balanced on both sides of the reactions. The number of molecules doesn't have to be necessarily, right? Because they can rearrange, these bonds can break, new bonds can form. All right, so just remember, molecules are made of atoms, right? So anytime we have a molecule, it's made up of several atoms. All right, we can use different colors to represent them. All right, and they would all have a chemical formula. The chemical formula would tell us how many of each atom are there. All right, how many of each atom are the subscripts? All right, we cannot change those. H2O, it is always 2 hydrogens to 1 oxygen. That is its fixed ratio. That is its chemical formula. We can change the subscript in front of it. 2 H2Os would be 2 oxygens, 4 hydrogens. 5 H2O molecules would be 5 oxygens, 10 hydrogens. All right, so 5 molecules of H2O gives us 5 atoms of oxygen, 10 atoms of hydrogen. All right, but the molecule is the whole cluster together. All right, and again, we are able to change the coefficient as we see fit. We're trying to balance these reactions. We want the total number of atoms of reactant to equal the total number of atoms of product. All right, so If we're looking at a formula like C8H18, those subscripts, 8 carbon atoms in the molecule, H18, 18 hydrogen atoms in the molecule. All right, so subscripts will not change. Multiple elements, that's our molecule. We are only changing the coefficient. All right, so if we had this reaction, Fe2O3 plus C, forming Fe plus CO2, we can make our chart. On the reactant side, we have 2 irons, we have 3 oxygens, we have 1 carbon. On the product side, only 1 iron, 2 oxygens, 1 carbon. So we're gonna have to use coefficients to balance this reaction. We're gonna need to balance the oxygen. So since we have an odd number and even, we're gonna get a 2 over here and then a 3 over here. That's gonna change our numbers of iron. That's gonna change our numbers of carbon. All right, so we'll get 2 Fe2O3 plus 3C, forming 4 Fe plus 3 CO2. All right, so this video just kind of reminds us of how to balance a chemical reaction. It's a skill we were practicing in class. We were really good at it. So your weekly assignment this week, and I'll explain it all when I post the assignment as well, but this video goes with it. You are going to draw out 5 chemical reactions, 1 of each type. So synthesis, decomposition, single replacement, double replacement, and combustion. And what I want to see in that is I want to see the reaction balanced. So you got to think back to that PhET that we were looking at. All right, that simulator. You want to show the molecules. All right, you want to show everything visually. You can use ball and sticks if you want. You can use a different form. That's totally fine. Now, this is a project we would have done in class. You would have had class time. So I feel good about giving it to you to complete this week while we're not in school. You can do it on a poster paper and take a photo of it. That's totally fine. You can hand draw the whole thing. That is totally fine. You can make it in any software program you want. I mean, you could make this in a PowerPoint. You could make it in a Paint doc if you really wanted to. All right, but the point is you have to give me 5 balanced chemical reactions. None of the reactions can be all balanced with a 1 as a coefficient. I'll post a resource with tons of reactions that you could pick from, but you cannot do a reaction where every coefficient is 1, and you have to draw it out kind of like what we see on this screen right now with the nitrogen, the hydrogen, and the NH3, right? We want to see the total numbers of each. So you're going to do 1 for each type of reaction, and then the 6th thing you're going to do, you are going to give me some type of example from the real world written out like a chemical reaction. And again, you have to show it visually. My example, if you had 2 pieces of bread plus 1 slice of cheese, you would make 1 grilled cheese, right? And I would show you the 2 pictures of bread, 2 slices, the 1 slice of cheese, and then the sandwich made together. It would have the exact same stuff, right? So think like the same number of atoms, the same amount of stuff, but it would be rearranged into some new, unique setup. So that is something that you are going to have to do by the end of this week. I'll have that posted today, all of the expectations on that. You can start getting it done. The second that you have it done, please send it to me. And that will be your weekly assignment for this week on chemical reactions. So it's a little more important than your daily assignments you'll get each day. All right, tomorrow's daily assignment, you will be playing through the game side if you look at the PhET. So we have a game that goes with the balanced chemical reactions, and that will be an activity that you'll be doing tomorrow. All right, but this is the weekly activity. And if you have any questions on it, please contact me. I'll write it all up. You'll see it in the Teams page. It'll be assigned. It will be due Friday.